Ooh, what's up, what's up, what's up, what's up? Welcome back. Today we're working on our to-do file system. So the idea is that I have tasks. They kind of like write them similar to what we're seeing in the top right here. I kind of like pre-write this stuff to try to like organize my thoughts, make sure that we have like, what am I going to do for today's 2 hours? What am I going to do for tomorrow's 2 hours? Because these streams are short, and it's if I don't focus and like line up what I want to get done, then it's easy to just kind of flounder and end up at the end of 2 hours having like nothing to show for it. Even if we make progress, like there's no like nice like story to what we worked on that day. So it's nice to have like small broken up tasks in 2 hour chunks that are like ready to go. And that workflow, what it ends up doing to me is it means that I have lots of 2 hour chunked work that like is dependent on each other, right? So like today I'm going to do the first part of the task, then tomorrow I'm going to do the second part, then the third part. And what that kind of means is that I end up with this like tree of tasks, right? Like instead of how I think that I normally see stuff organized as in like just a linear set of tickets that you have to work on, I end up with this like weird web of dependencies, right? So I have like, I'm working on my like image to text AI, and I might have like, I want to look at like black and white color automatic detection, and then I might want to look at like with RGB color, and then on the left side I might want to say like, oh, I want to like port this to like Rust or something so that I can run it without any dependencies, and then there I might want to like look at running it in the browser with WASM. Then from there I might want to look at like some sort of like web UI, and then I'll also from on the Rust side I might want to look at like SIMD, and then both of these guys would kind of lean towards like what does like WASM plus SIMD look like. Anyways, the point is that I have like trees of tasks, and when I look at like existing ticket tracking, task tracking systems that I've seen before, they don't really show what I want, which is like I want to see this tree at a glance, and I want to keep this like workflow of having just like a text file of my things in my head, where I don't want to like upgrade to some like web-based ticket tracker, because then I kind of have to then just port the stuff out of that web-based ticket tracker back into the file that I show in the top right. Kind of annoying, right? So justification to some extent for making my own thing. And so the question is like, why am I talking about a custom file system? Well, there are like multi-way links, right? Everything has like, if these relationships that I'm showing on this tree are like, say, blocks and blocked by, right? So I have like RGB is blocked by black and white investigation blocks RGB investigation. So there's like two-way relationships, and if I were to just like organize my files this way, I'd have to maintain all of these bi-directional relationships, which would be a bit of a pain in the ass. So what I'm thinking is, what's a simple way for me to get these links automatically handled in a UI that's like quick to bang out? And my thought is, a file system kind of like matches all of the constraints I want, right? Like I want to like just browse through folders and edit my files, and I can like have the fake file system automatically generate like the links between these things and like structure them. And like maybe I want to add like custom filters to say like, oh, I want to see all the things for this project, or I want to see all of the things that I can work on right now, or I want to see like all of the stuff that needs like post stream cleanup, things that need like thumbnails, right? Like I have like all these like filters that I might want to apply to this stuff. And I think that I can just add those filters as like other folders in the file system, essentially. So the project is essentially a database of files as well as links between them, and then presenting that through a custom file system to get different views into that data. What we're working on today is actually like adding these relationships. So what we have right now is we have like a database of, we'll call it database of stuff. And in here, there's like a metadata.db. And this guy just holds like a file ID and name. That's all he has right now. Then we have like items. And in here, we have like a folder 0, 1, 2, 3, etc. And these are just folders of shit. And so what I think that I want to do today is add here in the metadata database some sort of like table of relationships, right? So now he's going to have relationships as well as file relationships. So we can have like, we can add relationships of whatever name we want, and then add links to those things. And then we're going to have to find a way to show these. So what happens right now is this is like the back end, kind of, we can call it, and we can kind of pretend that our fake file system is like a client to that back end. And right now, all we have in our client is we have by ID that basically just maps to like this item section. So we're going to have to get a little clever there, and maybe we're going to want to do something like item 0 is going to now have content, which will map to db items 0. And then we might have something like blocks, right? So if we have like a blocks and blocked by relationship, then in here we can have kind of like symlinks to all of the items that this blocks. So like, you know, we'll have a symlink to 1, symlink to 2. And that's kind of where I want to get to today. Yeah, I think that kind of sums it up, and I think we can just kind of get into it. Hey, did you look at Task Warrior? I think most of the features are there. I did not look very hard, I will admit, because when I thought of what I wanted, I was like, I feel like that should be easy enough for me to write, that I don't need to look super, super hard. I feel like I don't need a large feature set, so we'll see. It's kind of fun to do this anyways, so while there may be something in the world that already provides what I'm looking for, it's kind of more fun to do it this way, and I kind of want to see where we end up, and then maybe I'll take a look to see if there's something else that fixes it better. It's kind of like, you know, like when you like are preparing for your math test, and you're like doing practice problems, and if you look at the answers too early, then you don't learn what you wanted to learn. And so like there's kind of like everything that I do here is kind of like tainted by the fact that it's fun to try stuff, right? Which makes stuff like this, if there is something that exists, it's more fun not to find out about till after. So let's just leave it at that. Okay. So I think the like plan of action is we're going to add the relationships to the database in some way. Then we are going to like have to update our client layout so that we have this like ability to add custom traits. We call them like add the relationship folders. Then we'll actually like try to hook those relationships up. And then if we get to that point too quickly, then we can look at finding a way to like modify the relationships. Because like I'm kind of imagining that state 1 will just be that we edit the database manually, plug in our relationships, and deal with like addition and removal of relationships later. But if we get to that point, then we can try to find like an interface that we like to modify relationships as well. Okay, so we have our database. All he is a bunch of folders as well as a metadata SQLite database. So one of the things that we're going to want to do here is we're going to want to create 2 tables, I think. One that's like a relationship, and he's going to have, what's he going to have him in? He's going to have like ID for like relationship ID, so that we can reference him from another table. And then he's going to have like, since these like relationships are kind of like, they're one relationship with 2 names, if that makes sense. So if you have like a parent-child relationship or a blocked by relationship, these are like the same thing, except just like based off of which direction you're kind of moving in. So I guess we'll call it like from and to. So then we could have something like 1 parent-child and 2 blocks blocked by, something like that. And then these will just be the names that we present in the file system. And maybe we'll use plurals here because the relationships are going to present many items generally. So having just having a plural with 1 item in it still makes sense, I think. Yeah, okay. And then what we'll do is when we actually want to like connect these relationships, we can say that we'll have like, we'll call this relationships, and we'll say item relationships will have what in its table? It's going to be like from ID to ID and relationship ID. I think that makes sense. So if we have like item 1, no. Yes. Yeah. So say we have a relationship like item 0 blocks item 1. And we have relationship, we have ID 2 for the blocking relationship. We could then say that we have 0, 1, relationship ID 2. That's how this is stored in the database. And then we should be able to go both, when we look at ID 1, we should be able to say who blocks me, who am I blocked by, and from 0 we should be able to say who do I block. And I think that makes sense. I don't think there's anything missing there. So I don't know if I have to do like separate executions here. I can probably just batch them all at once. So I think that I can just shove a semicolon in there. Is that how they do it in SQLite? Let's see. SQLite multiple statements. I think it's just semicolon. This is Python. Can we look at like RusQLite examples maybe? And maybe somebody will... They do seem to be doing one thing at a time, which is pretty reasonable. I guess we can just do it that way. So we can say, we'll create table if not exists relationships. ID is a primary key, and then he's going to have from, or maybe we'll call it name, from title, from name. Yeah, sure. Text, not null. And to name is also text, not null. And then we also want to create a table for relationships or item relationships. Relationships. And we have no primary key here. We just have from ID, to ID, and relationship ID. And then we can add a bunch of like foreign key constraints on here. I think we can say like, hey, SQLite, make sure that when I like use this, that he links here, this links to here, and this links to here. But I don't remember how to do that, so we're gonna have to Google it really quick. Foreign key constraints. And we probably should also say that these are all integers. I think like this. And here, someone should say foreign key. Here we go. Yeah. Foreign key from ID references files ID. And same for to ID, and relationship ID references relationships ID. And I think all of that is probably fine. Primary key would be all of them together. Is that true? I've never... my SQL is not very good. SQLite primary key. Let's see. Primary key. Optionally a primary key. Primary keys are supported. Both single column and composite multi-column primary keys are supported. Interesting. I would just think that there's no primary key though, right? We're not ever doing like a lookup based off a key to a value. Like this just is, the whole thing is like the data as a whole. I don't know. We'll see. We'll see if there's like a reason to get into that, but I think that I'll just leave it without specifying and we'll see what happens. We'll see what happens. Very likely we'll find out down the line that there's a reason to do it differently, but I'm all into fucking up and then discovering why I fucked up later. Because I'm not writing ever production software. It's all for me all the time. Hey, how's it going? Good to see you. Are those oh my dog? That's a funny emote. Okay, so I guess what we can do is we can just run our application. He's going to construct the database, which should add those new tables, and we can see if he fucking crashes. So we'll just run him. He does crash, which is good. Near foreign, syntax error. Okay, so we fucked up here. Where was the foreign key constraint stuff? Ah, it has to go inside the create table. So, like this, I think. He still doesn't like that. Foreign syntax error. What the fuck am I doing wrong? So, create table, blah, 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 foreign key, blah, references, blah. Oops, I fucked up my brackets again. There we go, he likes that. And so now if we open the database, sorry, just quit this. We open a new shell so that we can use SQLite browser. SQLite browser, test-db metadata. We should now see two new tables, item relationships and relationships with nothing in them, solid. And we can just add some test relationships just to see. And I guess we'll just, can we just modify this in here? So let's make a new relationship, item ID 1. And from name, we'll call him blocks. And to name, we'll say blocked by. Okay, and then can we just blocked by? Can I just write that? Oh, he doesn't like that. Do I have to? Why doesn't he like that? Maybe I have to just like manually punch something in. Do I have to like actually execute SQL or something? Insert into relationships. Values. Relationships. Do I specify here? I always have to look it up. Background and Vim. And we can look at DB, and I've done this somewhere here. Insert into files name values. Okay, yeah. Insert into relationships from name to name values blocks blocked by. Okay. And then can I hit play on this? Looks like that should work. And now I actually have that thing there. Oh, I was trying to filter like an idiot. Okay. That's good enough. Right changes. And then we should be able to say insert into item relationships. Relationships. And what are my things in here? I have from ID, to ID, and relationship ID. So from ID to ID, relationship ID. And the values are just going to be, I'm going to say that item 1 blocks item 2 because of relationship ID 1. Hit play. Looks like that's fine. And if I look at my item relationships, I have from ID to ID 1. Perfect. So we can write those changes out. Is that actually what I want to do? Maybe it makes sense for me to stub out the like add relationship interface to the database now. Yeah, let's do that. Let's do that. We should at least have, even if we don't hook up to the file system immediately, we should at least have the ability to do it through the interface. So we'll say add relationship, and he's going to take self, and he's going to take a name of the relationship, or he's going to take the from name and the to name, and he's going to have, for now, we're just going to crash if he fails because I don't want to deal with error handling until I have a good idea of like that this prototype is going to continue existing. And I guess if we want to, we are going to have to return a relationship ID actually, because we are going to want to add a relationship and then immediately apply that relationship to someone. So that seems reasonable. Okay, we'll do that. So we're going to say insert into, we already did this, but now we're doing it in code. So I guess I don't have it ready to copy paste. So relationships, from name to name, values 1, 2, and we say from name to name, easy, transaction commit, unwrap. And we also need to get the ID. So we just go womp and return relationship ID. And then we have to make that relationship ID type. So we're just going to say pub struct relationship ID, takes an I64, but the I64 is not public because we don't want people to manually construct those. We should only be able to get them from our database. I guess theoretically we should also, if we want that to be true, there should be a way to like resolve relationships by their names. So we can say like find relationship by its from name, I guess makes sense. And this will, the relationship may not exist, so this will return an option. And we are going to what? Self connection, prepare, select ID from relationships where from name equals this thing that we pass in. I think that's how you do it. I don't know. We'll see in a second. And we just pass in from name here. And then we unwrap. We say let statement is equal to this. And then we actually execute the statement. So we say statement query map. Statement query map row. Well, let's see. What are like my options here? Rust QLite in docs.rs. What are my options? Statement womp womp. So I can execute, which gives me a result. That's just the number of rows. That's not really what I want. Query kind of sounds like what I want. And that's, yeah, I'll probably do that. Query. And he gives me back rows that's like kind of like an iterator, but not quite. Or query map. Yeah, query and then fuck it. Yeah, okay, query map seems reasonable. Query map seems reasonable. Okay, so we unwrap here and we're gonna have what our rows is going to, we're not gonna collect this or anything. I don't think we have to. So we can just say .next on here. And we just say, if we get a row get 0. So let ret I64 equals row get 0. Return ret. And this has to be okay. All right. And do we have to unwrap this like this, maybe? What's he bitching about? This is not a vector thing. And here we have to put a question mark. And is this, I think this all lines up. And I guess we have a future. What if there are duplicates? But for now, we ignore that. And then we just return item, actually, I think. Oh, we have to map. The item is going to be the thing that's returned here is a result option result I64, I think is what this should return. So I'm just going to say item unwrap like this. And that should turn it into an option I64. But this shouldn't be an I64. It should be a relationship ID. Because we're strong typing, baby. And then I think everything works out. The query goes in here. Cannot bar statement is mutable, so we just shove a fucking mute on there. And probably that all works. So let's test that. So here we can say print line. We'll comment this out and we'll say the relationship ID is going to be db find relationship blocks. And this should be like this, debug, and this should be mutable, boom. And cargo run now. And we do find the relationship, which is good. Seems good. And then we just need a way to, we should check if we add a relationship now. So first, I guess in our main, we should also test that blocks 2, like if we just, or we type like blocked by or something, and we should see if that one should be none. There isn't a block by. Good, okay. And then if we add one, so we say db add relationship, we can say parent children. We can see what happens there. Probably we should then be able to find that relationship, or maybe we'll just print out what it returns, just to make sure everything lines up. Okay, so we get a new relationship. Probably if we run this again, it'll crash. Oh, okay, so it just added a second relationship with the exact same name. So that's going to be a problem for us. So this add relationship, maybe it should first check if that relationship already exists. So let's see. We can say if find relationship by from name is, we can say if let sum ID is equal to this. We then just say fuck you and return that. We just don't insert it. And the to name is just ignored. And we maybe like warn here. Let's just add some logging here. What is it? mvlogger? Is that the one that people use? Yeah. mvlogger. Yeah. Okay. So here we can then say what? Log warn relationship with from name already exists. And I think we can just actually write from name in here. And then we return ID. Boom. Cannot borrow self as mutable, so we should do this before we create the transaction, and then that makes everything work out. And now, if I cargo run, we actually probably have to initialize nvlogger for this to show up, so we can just say what, nvlogger init or something, probably. I don't remember. We'll see. It'll bitch at us in a second. It will bitch at us in a second. He doesn't need to unwrap. There we go. And we don't see any warnings, which is kind of surprising. So why is that? Do I actually have to look at the documentation? Seems like it should work. Rust log, maybe my log filter is too high? Yeah, okay, it was only showing errors. Okay. Cool. I guess I don't really like the way that log looks. I kind of want this to say, like, put quotes around it or something. Yeah, okay, cool. Cool. Works for me. Works for me. Now we want to add item relationships. So add item relationship. And he's going to take in the ID of the source. From ID is going to be a what? Item ID, I guess we'll call it, which doesn't exist right now, but we'll have to make one. To ID is also an item ID, and the relationship is also going to be a relationship ID. Yep. And that should be easy peasy. So we just yoink this, insert into relationships from ID, and it's not relationships anymore, it's item relationships, from ID to ID relationship ID, and these values 1, 2, 3. And so we say that the items in here are from ID thing inside to ID thing inside and relationship ID thing inside. And now we just have to make item IDs. So womp item. And then here we're gonna replace this I64 in our DB item with item ID. Now what's kind of weird here is we actually do need this to end up being public because the file system is logging IDs based off their numbers. So we actually just need to like pub this guy, which kind of sucks. And then in our fuse stuff, wherever we used .id, we just say .id.0. I think that's the only place. Build 154. Nope, 154 here. This guy needs to be an item ID now. So let ID is equal to item ID. Boom. And boom. Boom. Okay, so that builds. And did we need to test that? So add item relationship. We'll just quickly say db add item relationship, and we'll get item ID 1, item ID 2, and relationship ID. We'll say parent relationship is equal to this. Okay. And then we say parent relationship. Okay, almost there. Could not find thing because this comes from DB like this. Cargo build, cargo run, and we should now, if we open up the thing in SQLite browser, we should see a parent-child relationship on some of these guys. So here we have a from to relationship ID. Oh, he doesn't have the one I expect. What the fuck? Add item relationship. I didn't commit the transaction. Cool. Transcation. God damn it. Transaction. Everywhere over transcation should be transaction. Okay. Cool. So let's run it again. Boom. Check the output. Browse data, relationships, item relationships. There we go. So we've got a relationship between 1 and 2 of both blocks and parent-child, which is fine. These may not be like, I know that these kind of, I'm not sure if having both parent-child and blocks like makes sense, but it's fine for now. Now we need some way to like see the relationships for each item. So I guess each, like for the item itself, he's gonna want not just the relationship ID, but like what direction the relationship is going. So he's gonna have relationships. It's gonna be like a vector of things, I guess. And we can then say that the relationship is going to have an ID like this, as well as a direction. So enum relationship direction is going to be public, and he's going to be like from, I guess we'll say from or to. Does that make sense? Source and dest relationship. So I as the item, I guess calling it from and to makes sense. We'll have to be careful with this. The naming feels sketchy. It feels like it'd be easy to be like, oh, I am going to that guy, or I am on the to side of the connection. So maybe I'll call this, instead of calling it direction, I'll call it relationship side. Relationship, sure, and then I can say source and dest. And that should be harder for me to fuck up in my head, because the source goes to the destination, Okay, yeah, and so things come from the source and go to the destination. Okay, so then we have the side of the relationship, which might make more sense. I don't know. It's good enough. Good enough. And so here we have a relationship vector. Vector of relationships, which now needs to derive debug on all of these. Bump, bump, so that they're printable. And okay. So now this guy needs to have his relationships on here. So we need to do probably a join on here. So you select ID name from files, join. Let's think about this. Let's think about this. So we have files ID name, relation, item relationships, from ID to ID relationship ID. So we just want to join on either from ID or to ID equals my ID. And then I have to double check what the types of joins are. SQLite join types. There's like left join, inner join, outer join. Okay. I just want a left join, I guess, because my ID is always going to be on the left side, and I don't want to like introduce items where they don't match or something. Sure. Okay. So left join syntax SQLite. God, it feels bad when I go to sqlitetutorial.net. Damn. Okay, so left join from this table on this thing. Okay. Okay, so I want left join item relationships on from ID is equal to ID. Is there, can I do like or on here as well? SQLite join. Surely there's like where's like the actual thing here? Join operator, okay. Left, right, inner cross, okay, so that's not what I'm looking for. I'm looking for table or subquery join constraint. Here we go. On expression. Okay. Where this can be just anything. Okay. So we can just say on from ID equals ID or to ID equals ID. Okay. And then we'll just say from ID to ID relationship ID. And can I like specify, do I just specify the names here? I guess that makes sense. Item, can I specify like, can I alias the names here? I can't remember. SQLite join. I'm pretty sure you can like put like an as here. Join artists are on our blah, blah, blah. But can I like alias? SQLite join as. Join table alias. Okay, it's not coming up when I Google immediately. I'm pretty sure it's like possible. Oh, using. Here we go. SQLite join. And let's go back to this, and we can go back to, was it join constraint? Using blank. Oh well, whatever. I think that this is fine. So we'll just say item relationships dot this, and we'll say files dot this. All right. So now we have ID is this, name is this, and then relationship from ID is equal to row get 0, 1, 2. Let relationship from ID. Hold on. This doesn't make sense. Doing a join this way, there could be many relationships here. So there's not one unique version of this. So I guess actually maybe what I want to do is not join here, but for each item, do like another query, which I think is stupid. I think you're not supposed to do that. I guess we know that we're going to be iterating all items. We could just look at all item relationships and have them have like a lookup ready for them. Does that make sense? How do I want to do this? For now, I think it's fine to just... Here's what we'll do. We will start, instead of this returning DB items directly, we're going to make a file or item here is just going to have ID as a item ID and a name as a string. Here, instead of giving back DB items, we're going to go get items. Okay. Then, for each item, we're going to execute a new thing to fill in the rest. So, we'll call, I guess at this point, the statement is done. So we can just create a new statement here. And we'll say, select. Yes, this is making sense. We'll select from ID to ID relationship ID from item relationships. Okay. Do we want to do like one select per ID? I guess like we could just grab everything because we are iterating all items, which means that we will eventually need to look at every single relationship. So that seems reasonable. This is items. It's going to be this. Okay. So for item in items, we're going to look up relationships. But we want to get all the relationships first. So we'll say let relationships item relationships is equal to statement dot query map. No parameters. Each row, we are going to get the relationship. So we're going to say struct relationship. Oh, we already have a relationship struct. Fuck. So here, I'm going to map which side of the relationship I'm on. That doesn't make sense. So we'll just call this a DB relationship for now. Kind of like fucked up naming, but whatever. And this is just going to have from ID, relationship ID, to ID, relationship ID, and nope, from ID is an item ID. There we go. And relationship ID is a relationship ID. Okay. Sure. Then we're going to iterate over each row and convert these things into a DB relationship. So it's going to say let from ID is an I64 equals row.getZero, 1, 2. And these are going to be to ID, relationship ID. We return a DB relationship. Okay. Yep. Okay. From ID is a item ID from ID to relationship. Okay. Oops, I didn't mean to close there. Okay, so now we have all of our relationships. And this is unwrap, and map x dot unwrap for now. And this is going to be a vec of DB relationships. Okay. Now, this should be some sort of like lookup, but that's okay. We're just going to use it as a flat vector for now. And we're going to say for each item, we are going to look up the relationships it has. So first of all, if I write unimplemented here, does this still compile? Cargo check. No. Why not? Am I like... Why does like my thing think I'm indented too? That's weird. Oh, that's fine. Iterator, the trait, blah, blah, blah. What is it complaining about? This is not an iterator. Oh, because it can't resolve the type unless I actually return something. Fuck. Okay, so we'll just, for now, we will write let ret is equal to vec new, and we'll say ret dot into iter. And that should now compile at least. Yeah, that compiles, so everything is up. We're on the right track. So now we say, I guess we say for item in items, we find all the relationships that we're in. So for relationship in DB relationship or item relationships, yes, okay. First we have to make our, what are we going to do here? We're going to say let relationships is equal to a new vector. And as we move through all the relationships, we're going to say if relationship dot from ID is equal to item dot ID. We're going to push a new relationship. So we're going to say relationships push relationship. Yes. Okay. So ID is the to ID. Who am I going to? And side is going to be the source. Okay, that's lining up so far. Oh, and this is actually, this should have the, this is the relationship ID. So this is a relationship ID, which means that actually our relationship is missing a crucial component, which is pub sibling. Who am I going to? I think that makes sense. So here are all of my connections. Yeah, okay, that seems right. So here is the relationship, here is my who I'm connecting to, and this is which side of the connection I am. Yeah, okay. And maybe we should call this like, that's fine, it's fine. So we are the source, and our sibling is the relationship to ID. Okay. Okay. And then we say return push DB item. Path is, fuck, we deleted this code, but it's self item path join the ID, so item ID to string. I think that's it. I think ID is the item ID. Relationships is relationships, passed in already, and we are missing name, which is item.name. All right, and then we also have to do the other side. So if relationship to ID is equal to item ID, we do the same thing we did here, but we push from the other side. So boom, boom, sibling is from ID now, and we are the destination. Yeah. Yeah, and then here we need to derive EQ and partial EQ for that to work. Okay, and I think that might be fine. I guess these relationship IDs need to get cloned. But relationship ID can just derive, clone, and copy. That's fine. Doesn't fucking matter. And so can item ID. This guy can also just derive, clone, and copy. Okay. I think that compiles, which is nice. And whoa. These are broken. 2ID and relationship ID. Okay, and now we'll go back to main, and we're going to iterate all of our items. And let's just print out the item, and we can see if the relationships match up. Now, normally, I would write unit tests for this. But I don't want to. Like, the correct thing to do is to, like, test this, like, add, addition, removal, and, like, relationship mapping. That all, like, lines up. And I'm kind of just, like, unit testing in my head by writing these, but, yeah, it's just, I'm worried about running short on time today, so I'll probably pack in those tests later. Okay, so we have a test. We have an item at testDB items 1 who has a relationship ID1 with ID2, and I'm the source. And I also have another relationship with item 2 where I'm the source, but this time it's relationship 2. And from the item 2 side, I have a relationship with sibling ID1 where I'm the destination for relationship ID1. And I should have... Oh, there were 3. Hold on. Whoa. Why is there a duplicate in here? Why the fuck is there a duplicate? Is it duplicated in the database? Whoa. Ah. There is a duplicate. There's a duplicate. Why? Why is there a duplicate? Because I'm adding it here. And so here we actually have to do this. We have to check before we add it if that relationship already exists. So can I do like insert into if not exists SQLite? Is that like a thing I can do? Insert into, oh my god, that's insert or ignore into. If it was a primary key, it would fail. Right, so I could say that I want, when I create the table, create table, if not, I could make a, I could say I have a constraint here, unique set of from ID to ID and relationship ID, which should do essentially the same thing. I guess unique, yeah, that's fine. That's fine. Which means that I probably have to nuke the database. I can just nuke the table. I'll nuke the table, and then I think all of this should work. So here, I will go into my relationships. Oh, it's just a drop table item relationships. Run. Write changes. Okay. That's fine. Then I should, okay, that's gone, nice. And I should be able to cargo run. And if I run again, we fail on inserting because we violate the unique constraint. Nice. And so we insert or ignore into item relationships. And now this should work. Boom, baby! Let's go! And let's also add the... That's fine. That's fine as is. Okay, so we have one parent-child relationship. And I think we can probably call that add items to DB done? Probably. I think that we're at a point now where we can like interact with these things and visualize them from the file system. I think. Okay, so right now, our file system, if we actually run it, cargo run test mount, I look at test mount, and I look at by ID and item 1. So here, the content of item 1 is directly the content in the database. If I look at testdb items 1, it's like the same shit, right? And now I want to say that like item 1 has relationships into it. So I think what I want to do is I want to say that I have by ID 1 right now goes to items 1, and I think I want to do by ID 1 content goes to items 1, and then I can have something like by ID 1 children, and this can be have a folder of symlinks to my related objects. That's kind of what I'm thinking right now. So the first thing we need to do is actually move these guys. So we have right now we have like paths that we get from the file system. They say this is the directory I'm in, and we say we have like the root that we handle in one way, the like by ID folder that we handle in another way, and I guess we just have to make sure testdb is the data and test mount is the fuse mount. Yeah, exactly. Sorry, that wasn't clear. So here we have a by ID folder where we list all of the things, all of our items, and then I guess we should say we have a new thing now that has an item and his ID. Item ID makes sense to use here. So this is the like root folder, and then we'll have another one that's like item. I guess item content is the same as the DB path. Okay. That makes sense to me so far. So this mapping to DB path is wrong. And so we should only be doing this if we're in a content folder. So if we're in by ID, so I guess we need to like deconstruct the path here. So we can maybe say function matches item content folder, and he takes in a path, right? And he returns a bool, true or false, easy. And we are going to deconstruct the path into its components. So path dot certainly one of the things we have here is like an iter over the items of the path, probably path. Iter provides an iterator over the path's components viewed as OS string slices. So we get temp and food. Perfect. That's what I want. So we're going to say we iterate over the things. We want to take the first one. No, we want to... how do I like skip one of the components? Because we're going to have... this is going to turn into by ID 0 content, other shit. And we basically want to say if the first item is by ID and the third item is content, then the second item is a content folder. And maybe this is actually going to turn into an option item ID, right? If it matches, we'll return the item ID it matched against. Otherwise, we do not return anything. And so is there a way for me to... Okay, here's what we'll do. We'll say path iter. We get the iterator. We say first is equal to it next. Let ID is equal to it next again. And third is this. If first is equal to sum by ID and third is equal to content, return sum ID, and we have to parse this as I64, unwrap him if he fails, and then cast this to put this into an item ID. Okay. Otherwise, return none. Certainly he doesn't like that in some way. So he doesn't like that these strs are not OS strs, which is fucking annoying. How do I make an OS stir? Oh, yo. So I can just write OS stir new. Okay. OS stir new, like this. And OS stir new, like this. And then we need to use stood FFI OS stir. Okay. Cargo check. He's still mad about something. So I missed a sum here because it's an option. And he doesn't like that ID is an option. So here we know that this is full now. Because if we had the first and the third thing, the second thing must exist. So ID should exist if content exists. Okay, easy. So we can't parse an OS stir. Fuck me, man. So we can say to stir expect. Here we can say that since we are in control of the names of the files that come out, if this thing doesn't parse to a string correctly, that's like a fucking bug. This isn't just like ignoring error handling, which is where I would use unwrap. I think that this is like actually an assertion. This should never fucking happen. So we can say ID should always cast to string. And in fact, we can do this here. Okay. So let ID is equal to this. And you should also maybe then argue that since we're in control of what files are in this folder, it's also a bug if this doesn't parse into a string or into like an integer correctly. So we can say parse as an I64, expect ID should always be a number. And I think that's reasonable. This isn't just like ignoring errors. This is like actually the program is fucking buggy if that's happened. So works for me. And so now we can say if, instead of doing this, we can say if let sum item ID is equal to, what if users do ls by ID something content? That's a good point. Eh? I didn't really consider that the paths can come from something that doesn't already exist in there. But you're right. They can. Okay. So we'll just go back from writing expects. So this expect is reasonable, but these ones are not. Unwrap. But it will be string. I guess there's like theoretically they could put something that's not UTF-8 in there, and I don't know if that might fail. So we'll just write unwraps here to flag to myself that later I should fix that. So we can say else if we let some item ID is equal to matches item content folder. Then we can find the corresponding path. That makes sense. So this now joins with item ID 0. No. So what did I do before? I had strip prefix. I see. So now this should map to the database path. So I actually need to like look up the database path for this, I guess. Fuck, this is so confusing. So here I'm gonna have like by ID 0 content some stuff, and I want to map this to fs root items 0 some stuff. Okay. But I guess like from my perspective, I don't actually know that this is items, so I should be asking the database where items are stored. Oh, which I am. That's fs root, so this is just like this. And I guess like theoretically, I shouldn't know from my perspective as the fuse file system that that like the item ID is the folder I'm mapping to. Can I like ask the database for the folder? I think that makes more sense. So we're gonna say pub function, content folder for ID, takes himself and an item ID, and he returns a path, and he maybe a path buff. Yes. And so now we can say self item path join id.0. And then like it's kind of like encapsulated in the right spot, which makes sense. Why doesn't he like that though? Required by a bound introduced by this call. Oh, this needs to be to string. There we go. Okay. So now our full, and I guess we should canonicalize this as well, like this. Okay. So now we can say self.db content folder for ID. We pass in the item ID. Yes, this is coming together. Okay. So now, what we're missing probably, well, let's run this and see what we're missing. Cargo run. I'm pretty sure that we're missing a crucial piece here, but we can just look. The test mount by ID 1. And so now each items folder doesn't show anything because it used to map. So we actually have to have here, we have to return the item path sometimes. Yes. So here we're going to say else if. So if it didn't match a content folder, we can, I guess we'll say matches item folder here. And we'll return an optional item ID again. And this is going to look very similar. But we're just going to say third here. The expectation now is that third is none. Otherwise, well, yeah, that makes sense. If the third is none, then we're in the item folder. And the ID should still work. Everything else still here is the same, and we'll just say here, down here, else if let some item ID is equal to matches item folder. We will then return an item, fuse client path item ID. And all we're going to do in that case, when we list the directory, in matches content folder, you need to check if fourth is none. Oh, that's a really good point. Good catch. No, I don't think so. Because any subdirectory should also match the content folder, and the path should just match. Oh. Yeah, I see what you're saying. Yeah, you're right. So here we actually want to like strip off matches item content folder maybe shouldn't return like the item ID, but should return like the path as well. Yeah. So this is going to return item ID as well as a path. And we'll call, this will then just collect the rest of the path back. So let remaining is equal to ID collect. And then we return sum and remaining, which is going to be a path buff, I guess, which means that this has to be, or maybe I can collect this into a path. I actually don't know. We'll find out real quick. Expected 1, argument found 2. So this should be like this, I guess. And I guess this maybe has to be a path buff because he's complaining. Path buff. Cannot find path buff, so here we need path buff. Wow, that's actually surprising. I didn't really expect that to work so well, but it looks like that does. So now here we can say some item ID remaining, and then we have the full path dot join with remaining. Wow, does that actually fucking work? That's shocking. Let's print this out. So full path. And so I can cargo run. And we can ls test mount by ID 1 content ASDF BSDF. And here we actually should somewhere see that print. No? Hold on. Print line, we should say here, matched item, and then we can see if that shows up anywhere. So ls test mount by ID, and we can look for matched. And that doesn't come up ever, actually, so that's interesting. So can we print line here, and we could say print line checking for match on path, and we put the path. ls test mount, so check for match on path by ID 1 content ASDF BSDF. And so that actually seems to be failing. Which is interesting. Interesting. So let's print out first and third, because it doesn't seem to be doing what I want. Let's see. ls test mount. So first, fuck, we're off by 1. We are off by 1. So just on both of these guys, we have to consume root. There we go. Odd, but it is what it is. So now, ls test mount. Checking for match, blah, blah, blah. Matched item, home work streamer to do TestDB items 1 ASDF. Huh. Why does it not get the rest? Oh, because ls is maybe being a little tricky here. He's checking if the files exist. Okay, sure. So that's fine. We can like look at testdb. I think we should have an item in here. Fuck off. Okay, ls star. One of these should have a subfolder. Items 2. So we should be able to try items 2 content hello. I think we can even touch something. Yeah, okay, that's working. Looks like that's working. Yeah, okay, sick. So now we just have to fix the fact that the content folder doesn't show up in here, which should be pretty easy. We should be hitting this case, which means that somewhere we should have unhandled path item. Nice. Here we should, this is in the reader. Use client path item ID. And now all we have to do here is print out the content folder. So we'll just say filler buff content, but I guess we need to convert content into a C string, which means we have to say let name is equal to C string new content. And I guess we may even be able to do C-stir. No, you have to do C-string because it needs to allocate and push a null terminator on there. Name as pointer, SE pointer null 0. Okay. So for every single item, we're going to drop a content folder in there. And so now if I go into test mount by ID 1 content, nice, baby. All of that to get something so simple, but now we're in a state where we can add secondary things on here. So let's do a little git status, git add-u, git commit-m checkpoint, just so that we don't ruin anything. Okay. I did crash in here because somebody was trying to ls some stuff in by ID that was not a number, so we're gonna have to address that later. But for now, we do not, because I want to make sure that we get to the target here, which is that we have symlinks in there. So we've updated the item layout, and now we're at the part where we want to add in symlinks. Okay. So I guess what we're gonna do is in the item directory, we're going to make a new folder for each relationship, I guess. Okay, yeah, that seems reasonable to me. So we're gonna look over our item relationships, which means that we're gonna have to ask the database for our item. Okay, which means here, instead of having a thing that iterates items, we're actually gonna have to say pub function get item by ID. We're gonna take in self. We're gonna return an item ID, or sorry, we're gonna return a DB item from an item ID, like this. And this is gonna be very similar to these queries for the iterate thing, except here we're actually not going to request all relationships. We're only going to request relationships for ourselves. Okay, but this loop is going to be the same probably. Awkward. I don't want to do this right now, so we're going to take the shortcut. We're going to say self iterate items filter for we have items, and we're gonna say, or we're gonna each item. We're gonna say item.id is equal to ID. Next, unwrap. Okay, we're taking a little cheat. He actually doesn't. What's he bitching about? Cargo check. Is this like a Clippy shit? Cargo Clippy. He's telling me that I should try find. Sure, fine. I'll try find. Jeez. And we're just gonna put a fixie on here and say like actually only don't query all the whole database for every item lookup, idiot. There you go. But you know, again, sometimes you take some shortcuts. So here we have our ID. We're gonna say let item is equal to self. No, not self. Client DB get item by ID. And what are we gonna do? We're gonna say we're gonna like look for each relationship, I guess. Which means that maybe we don't want our relationships as like a flat vector. Like, does it make more sense to store this as like, show me all of the items with this relationship ID / side, right? We kind of have like a key, which is these two items, and a value, which is the sibling. But fuck it. We'll handle this on this side. Because I guess you could also argue that as the database, don't know how your users are going to use it, so letting them organize the data the way they want kind of makes sense. Fuck it, I don't know. Sure. Okay. So I guess what we're gonna want to do is we're gonna want to like categorize the relationships here. Item dot relationships, and then what we're gonna like iterate over each thing. So we're gonna say relationship ID and source, relationship direction, I guess we'll call it. Or maybe we'll just say relationship name. Yeah. So we'll get the name out of this. So blocks are blocked by and items. Okay. And then for each of those things, we're going to create a folder for those items. So all we're going to do is we're going to say, we're going to create a C string from the name, because this is going to be in Rust string form. So we're going to say that this is a C string from relationship name. Okay. And we're just going to make that thing. Relationship name. Nice. That makes sense. So we're just going to have a directory for every relationship for now at the root of the item. And now we just have to make this categorize relationships function. So somewhere we just write function categorize relationships, who returns string vec item ID, I guess. And he takes in relationships as a relationship vector. Yes. All right. So now we just need to import relationships. So this comes from here. Okay. All of this is making sense so far. And then what do we do here? We say let ret is a hash map, I guess. For now. Then ret into iter. No. This doesn't make sense. This can't return a tuple like this. This should just return a hash map of string to... Yeah, that makes sense. So we have collections, hash map. We return a hash map of things to vectors. I don't know if the order that we insert things will matter. I think that it's up to the file browser to sort them by name if they want to. So I think it doesn't matter if these guys are sorted by name, so you don't have to worry about using like a B-tree map or anything here. And we just say, for relationship and relationships, we're going to have to look up the relationship name based off of our directions. So we're going to say, I guess we also need the DB here. Yeah, that sounds right. And so that means this guy has to pass in self.clientDB. Okay, this isn't self, this is just client DB. Okay. And so here I have relationship ID. And we're going to get the relationships. We're going to say let relationship equal to DB get relationship ID, which kind of is fucked up because our DB, he's already said that the relationship is this, and so we just have to rename this to item relationship. And then we can, wherever we had our like DB relationship here, we'll just take this and stick it up here and rename this now to, I guess we'll just leave it as DB relationship for now because I'm concerned that I fucked up my renames. So we refresh real quick. Get relationship doesn't exist, so we just comment this out real quick. Cargo check. Okay, so there's no more remnants of the old relationship in here, which means we can rename this to relationship. And I guess, do I want this relationship ID stuck in there? I guess I kind of have to if I'm reusing this. All right, whatever. Whatever. I guess maybe I don't want this. I don't really want... What am I doing? I'm fucking high. Hold on. Undo. I just want a new struct. derive debug for pub struct relationship, not capital S, it's relationship one word, and we're going to say pub from name is a string and to name is a string. And this is what we're going to return when we call get relationship. And that seems reasonable to me. That seems reasonable to me. So we're going to say pub function. Oh, we have a find relationship already here based off from name. And so I guess we're going to just have another one that's like get relationship from the relationship ID. And he's going to return. If we hand out IDs, they better fucking be in there. So I think that's reasonable to just say it's going to return true. Later we might decide that that's not the case, but for now it's fine. And we're going to do select thing from relationships where instead of from name, we say ID. Cool. We execute this thing. This is the same shit, except we're instead of getting the ID, we want from name to name. From name is a string. To name is also a string. And we are now just returning relationship with from name and to name. Solid. This now needs to be ID, and this needs to be unwrapped. What's he bitching about now? This needs to be ID 0. And we are close now. I guess we can say item unwrap. Unwrap is our return here. So this is to relationship to relationship. And we'll say, we don't have to put fix me's on unwraps because we are going to grep for unwraps later. All unwraps should be banned, but for now, they live on. So now we can say let relationship is get relationship based off the ID. DB has to be mutable, which is surprising here. I don't think that is a reasonable constraint, so we'll just kind of yoink that off. Okay. And so we'll say this is item relationship now and relationship. And if we then like say the name is dependent on if we're the source of the destination. So if item relation, we guess actually match item relationship dot side. Okay. This is making sense so far. And if we are relationship side dest, we take the name of relationship. We have to be careful here. So if we're the destination, we want to map to the source name, right? Because we are, no, we want the dest name, to name. Because if we have like blocks and blocked by, we're the blocked by side. We want to list as blocked by our sources. Yeah, okay. So we list our side. Okay. And if we're source, we want to take the from name. Okay. Then we just say ret insert name item relationship ID. Okay. And this is not true. We want to say ret entry at name or insert a new vector. Let we have this is the name items is this, and name items dot push our relationship ID. And I think that's it. He's bitching about something. What is he saying? He's saying that the inferred thing is hashmap string vec relationship ID instead of item ID. So we fucked this up. This should be sibling is what we insert here. And this is why strong typing is fucking sick. right? If I hadn't done that work earlier of putting in item ID and relationship ID and splitting those, I would have fucked that up there, and I would have just not discovered it until later. So pretty happy there. Get relationship item relationship ID. Okay, so everything compiles, which means here we probably should get a single folder for some things. We should at least like we should see relationship folders for things that have relationships. So let's mount this, run the thing, ls test mount by ID 0. Fuck. Panic. So this panicked at dbrs 191. So where did he? So he didn't find an item ID with the ID? That's crazy. Why? Print ID. With as debug. And this should be print line. Oh, ID starts from 1. Good eye. So we just have bad fucking code. And we need to mount before running again because we crashed. So we exit cleanly. Nice. Okay, so 1 has a parents folder. 2 has a children folder. So I think we actually got the names backwards here. Because if I remember correctly, 1 is supposed to be the parent. So we'll just fix that real quick. So that's in the fuse stuff. Wherever we mapped the names, we just have to from name to name. Is that reasonable? Dest links to... Let's open the DB. I'm not really convinced that I did this right. So browse data. Item relationship. So we have from ID for relationship 2. Relationship 2 has parents, children. So 1 is parent. 2 should be child. So 2 should have parents, 1 should have children. So yeah, okay, so that makes sense. So here I'm on the destination, and I want to list parents, and here I'm on the source, I want to list children. Okay, that lines up. So cargo run. ls2 should now have parents, and ls1 should have children. Cool. Okay, so now if I go into children here, that should say unhandled path with an unknown type, which is good. And now I guess we have to fucking... Can we like easily map that like relationship back? We like... That's kind of odd. Odd. Let's think about this. How do I want this to work? So somewhere I can just list relationships? No. This is the listing of relationships. I guess I could... what if there's like duplicate relationship names? So say we have like... Let me think about this. What happens if we have like... we have one relationship that's like parents to children, and another relationship that's like parents to children. When I'm on the child side, I'll have parents and parents to, which is fine. And when I'm on parents to, I'll have children and parents will have children. And it seems like just merging those two folders makes sense. That's reasonable. But also, maybe I'll just ignore that case for now. I'll just ignore that case. So I guess we can have a new check here that just matches a relationship. So here we have matches. We have like these matching functions. Matches item folders, matches content folder. We'll also like make a new one that says matches item relationship folder, which is kind of sketchy for now, but fuck it for now. And here we're going to do something similar that we did here. So I'm just going to copy and then adjust. So here we're going to say we have the consume root. We have first ID, third will be the relationship name, and this will be the remaining. So actually, here we can assume that fourth should be none if we're in the relationship folder. Okay. So if we have by ID, third is, we have to check if it matches any of the relationship names. Okay. So here we're going to have to take in the database. And then we're going to say, let relationships equal to db get relationships, iterate get relationships. Okay. Yep. Which means that we have to implement that. Let's stub out the types now, and then we'll figure it out after. So here we're just going to create a pub function get relationships, takes in self, and returns, for now, we'll just say a vector of relationship. Unimplemented. Okay, so on this side now, we can say if, I guess we need to like resolve the ID from the relationship. So this is going to return the relationship ID, and probably that's it. Okay. So then we are going to iterate our relationships. Hold on, let's get this import working. So relationship ID gets imported. We're going to, if first is not equal to some os stir new by ID, we just return none. Now we don't have to worry about that. If third is none, we also return none. Now we don't have to worry about that either. Let third is equal to third expect. I guess we can do what? Let. I learned about this like syntax the other day that I didn't know about until very recently. It's like, wait, let some third is equal to third else return none. What fucking crazy syntax, eh? But this basically says, if third is something, we get it. Otherwise, we execute this block. Which is kind of like, I used to write this as let third is equal to match third sum v none return none. Which it's like arguably more readable. But this is like, this exists. I think this is one of those ones where I just would prefer to write the more explicit thing. Isn't this the same as writing third question mark? Oh, that's a good point, because we already happen to be returning options. Yeah, you're right. Which means that up here, I guess we can write just question mark here. If third is none, then we can't match the relationship folder. Yeah. I guess having it more explicit down here works out nicer for me. We'll put a comment here. Relationship folder comes from third. If none, it cannot match. Just whoop. Boom. Okay, cool. Okay. So now what? I guess we have to return the relationship ID and the item ID, probably. We're probably gonna need both of those. Probably. And yeah, that makes sense. So now we're gonna iterate all the relationships. So for relationship and relationships. Nope, we're gonna say relationships iter find relationship, and we're looking for the one where relationship dot from name is equal to third or relationship to name equals third. Okay. Yeah. And we actually now are finding that the relationship should in fact hold his ID because we want to extract it from this. So let's comment this out for a second and go back over to our database side. And where we get relationship, this is just going to have, he's going to also retrieve the ID. And here he's going to say ID is an I64 from row 0. ID is ID, but as a relationship ID. Okay, cool, which means that everything compiles again, and we can go back over here and come back here, say this, and for now, let item ID is equal to this item ID dot unwrap or expect. Item ID should always be valid if relationship folder resolved. Let item ID is equal to item ID parse as I64, and we unwrap this because it's not really reasonable to do for this, but it's okay. To stir unwrap. Okay, and the relationship ID. This needs to be a question mark here, and then we can just return item ID and item ID, and relationship ID from relationship.id. Yes. And that should be in sum. Okay. Relationship. Did I spell something wrong? Relationship ID. What is he bitching about? All right, whatever. We'll figure it out in a sec. These guys don't like that they are OS strings. We're just going to write to stir and unwrap these. Again, things will crash. We're okay with that for now. And fuck. This does not need to be cast to relationship ID. It already is one. Okay, so that compiles, and now we can check if we match the relationship folder wherever the fuck all of that matching is happening. So we can say else if we let some item ID relationship ID say matches relationship folder. Okay. We say that we now have item relationships for item ID and relationship ID. And do we want to store the side of the relationship as well? I guess we have to. So we can call this like what? Item relationship? No. Relationship ID and relationship side. I think we just have to store them both. Which means that up here, we need to get the relationship side. And here, we need to return the relationship side. Like this. Which means that down here, we return relationship. We have to switch behavior if we match from or to. Yeah. So we say let side is equal to match relationship dot no. We say let side is equal to if relationship dot from name is equal to third. We return side relationship side if we're batching from, then we are the destination because we're trying to list things that are on the sources. Else we are on the source side. I think that's right. And then we return side. I think. Maybe. It thinks that something's not closed correctly. Cargo check. 359. Oh, I fucked something up here. There. And here we need to pass in the DB. Okay. And then here we can say fuse client path. Item relationships. Item ID, relationship ID, relationship side. I hope that's right. Okay, and then we can run this now, and we can see how it fucks up. So, no implementation for this. So 321. This needs to say we'll just put. Can we just say that third is equal to third.toStir unwrap here, and then get rid of toStir everywhere? Yeah, that makes more sense. Cargo run. Okay, so that runs. And can I now LS's folder? No, because we unimplemented at DB176. Because here we didn't implement this get relationships, which should be easy. We create a statement and we map it to stuff. So we say, boom. We have select ID from name to name from relationships. Query map. There's no filters. We then try to find each one. So we have to say ID is 0. From name is a string. To name is also a string. 1, 2. ID is a relationship ID. And here we have, okay, relationship. ID from name to name. Easy. Easy. And then do I just like collect here, delete this? All right. Let's try again. Umount. All right, try again. ls. Okay. So here we have unhandled path. Item relationships for item ID 1 with relationship ID 2, where I am the source, which all lines up. Okay, so now all we have to do is get all of the other items that match this relationship ID on the other side. And list them. I'm sorry, I haven't watched all the streams, but how do you handle directories? So we have this like fuse function called readdir. And this gets called whenever somebody tries to list the contents of a directory. And we're basically just saying, like, based off of what we diagnose this path to be, like what purpose it serves, we will just run this function that will like put a directory in there. So what we're actually adding here is one where we have a new folder for item relationships, where we have item ID. Is that right? Yeah. Item ID, relationship ID, relationship side. And now we have to fill this according to some heuristic. All right, so what we're going to do here is we're going to say, we're going to, does our item have our relationships? It does. So we can say let item is equal to client db get item by ID. I will dig into the code after the stream. It's not on GitHub yet. It will be eventually, but we're not quite there yet. I kind of want to, I should probably get it onto GitHub probably after this. Before the next stream, I'll try to get a correct intermediate commit, because like we don't want to stack too much. Like where there's like prototype mode where we're like, I don't really know what we're gonna do, and then there's like finalize mode where it's like, okay, we have an idea of what we're gonna do and we can like checkpoint this somewhere. And I think we're getting closer and closer towards the side where the prototype is like, I'm pretty confident in the way the code's gonna look at this point, so it makes sense to start like committing properly. So I'll try to do that before tomorrow. So we have an item, we have the item ID, we can get it. We have an item now. Now we have the items relationships. Item relationships. And we can iterate over these and filter out where relationship, where the relationship ID is equal to this, and relationship side is equal to relationship side. Oh, that's easy. Okay, that actually, I love it when stuff just works. So that's straightforward, except that relationship side needs to have EQ and partial EQ implemented, as well as this guy needs to have EQ and partial EQ. Okay, that's sick. And then we can say, let relationship items is equal to this. Okay. For relationship... For item relationship in... We'll call this item relationships, I guess. Sure. For item relationship and item relationships, we can now just say filler buff name as pointer stood pointer null 0, and name is equal to, can we extract the name of the item? Probably. So we can say client db get item by ID item relationship sibling. Okay, so this is going to be sibling is like this. Then the sibling should have a name. Yes, sick. Okay, so then we can say name is equal to C string new sibling name. Probably clone here. Maybe ampersand here. Not quite sure if this guy... No, this guy wants this guy to take in the buffer that he owns, so throw a little clone on there. And for now, we're just going to say the name here. But I think here... So now we should have one child for item 1, test 2, and yes, test mount by ID to parents should have test. Nice. So these are the names associated with these IDs. And all we have to do now is symlink them. So we haven't implemented symlinks yet. So I don't actually know how to do that. But I think it's a little bit complicated. I think that read link fuse. I think that we have to both handle reading the file as well as a stat on it. So I think that what happens is you say like, we would here create a stat object that matches this, that like marks as symlink. And then when on symlink read, we'd have to return the path of linked object. So that gets a little bit more tricky, and I don't think I'm going to be able to achieve that in the next 5 minutes, which is about how long I have left today. So I think we'll call it there, and we'll say that we're kind of at the point now where we can at least we at least have linked them, and we have a way to like see which ones are linked. We can't see the contents of them because this instead of a folder should be a symlink, but we're like really far down the path, which is nice. Yeah, I think we'll call it there. Pretty happy with that progress, to be honest. Yeah, we got a lot done. Thanks for watching. If you liked what you saw, I stream most days at around 1 or 2 o'clock Pacific time for 1 or 2 hours. If you miss stream or you want to watch VODs where you can fast forward and shit, there's a YouTube link in the Twitch description. If you're on YouTube and you want to come swing by and chat about projects or whatever, give your input, tell me why I'm stupid, there's a Twitch link in the YouTube description. If you want to chat about projects while we're offline or chat with other people who are watching, there's a Discord link in the Twitch description as well. And there's also a GitHub link there where I should formalize this and get it into initial commit. I'll probably work on that tomorrow before stream. Yeah, that's it. Thanks for watching, guys, and I'll catch you on the next one. Bye!